All right, now we're going to talk about the Pythagorean theorem and other triangle stuff. So, yeah, it's just a whole bunch of triangle stuff. Now, the first thing we'd have to talk about when considering triangles is, does it even make a triangle? So if I'm given three numbers and we're assuming them to be the three side lengths of a triangle, does it even make a triangle? Well, to figure that out, for any triangle, the sum of the two smaller sides is greater than the third side. Strictly greater than, it cannot be equal to. Now let's think about some examples where this would not work. So let's say that I have three side lengths, 4, 7, and 20. If I have those three side lengths and I say, hey, is this a triangle? This cannot be a triangle, because if I have one side length of 20 and one side length of 7 and one side length of 4, these two sides can't touch. That doesn't make a triangle. A triangle has to be a closed three-sided shape. That can't be closed. Now, maybe we change this a little bit and make this 13, 7, and 20. All right, okay, well, 13 plus 7 is 20. Well, what does that do? If I have a line segment that's 13 and then another line segment that's 7, that just makes a line. That doesn't make a triangle. So the only way that you can have a triangle is if the two smaller sides add together to be more than the third side. So if I were to make this 14, 7, and 20, that would make a triangle, because, I mean, it's going to be a real thin triangle. It's still a triangle. That's 20. 14 would go to there. 7 would go to there. Still a triangle, because the two smaller sides are bigger than the third side. Or the biggest side, whatever you want to do. Whatever you want to call it. I don't care. What if it's an isosceles triangle? Maybe I have 7, 7, and 10. Well, those are the two smaller sides. Well, what if I have 10, 10, and 7? Well, there is only one small side, so I just have to say that the big side is another one. I just have to pick the two smaller ones. If these two are equal, I'm going to say that these are the smaller sides. But that would make a triangle, because 10 plus 7 is 17, and 17 is bigger than 10. So that would make a triangle. In fact, it would be an isosceles triangle. Cool. So that's the triangle inequality theorem. Yeah, cool. Next slide. The Pythagorean theorem, we may have talked about this already. You might have heard of this before. The Pythagorean theorem says the sum of the squares of the legs of a right triangle equals the square of the hypotenuse. That is a Pythagorean theorem, is this sentence here. This is the equation associated with the Pythagorean theorem. A squared plus b squared equals c squared, where a and b are the legs of a right triangle and c is the hypotenuse. So you can use the Pythagorean theorem to solve for any side of a right triangle, as long as you have two other sides. So if I have both legs, I can solve for the hypotenuse. If I have a hypotenuse and a leg, I can solve for the other leg. So, I mean, my favorite triangle, I know it's a right triangle, maybe the hypotenuse is 5 and the leg is 3. So then I have a squared plus 3 squared equals 5 squared. So a squared plus 9 equals 25. 25 minus 9 is 16. So a squared equals 16. I can take the square root of both sides and get that a equals 4. So as long as this is a right triangle, if I have a leg of 3 and a hypotenuse of 5, the other leg has a length of 4. Similarly, maybe I only knew that one leg was 3 and the other leg was 4. Well, 9 plus 16 is 25. So c squared equals 25. So c is 5. I know the hypotenuse has to be 5. That works for any right triangle. Now, lastly, what if you have three sides that make up a triangle, but the two smaller sides are not the sum of the two smaller sides squared does not equal the third side squared. Well, if it does, that's definitely a right triangle. If it doesn't, it's either an acute triangle or an obtuse triangle. Well, the question is, how do you tell? Well, if the sum of the two squared legs is bigger than the hypotenuse, that's an acute triangle. So maybe, let's draw a picture. So if the legs are bigger than the hypotenuse, then it's going to be an acute triangle, where each of these is an acute angle. If the two legs are smaller than the hypotenuse, it would look something like this, where that's an obtuse angle. If the hypotenuse is bigger than the legs, then it's an obtuse triangle. If the hypotenuse is smaller than the legs, then it's an acute triangle. Yeah, and that's the converse of the Pythagorean theorem. So, if you know it's a right triangle, you can solve for one of the sides. If you have all three sides, you can determine whether it's a right triangle or not, or an acute or an obtuse triangle, as long as all the sides make a triangle. So you can use the triangle inequality to figure out if the three lengths you're given even make a triangle. Then you can use the Pythagorean. Well, if you have all three sides, you wouldn't have to find the third side because you know all three sides. But if you have all three sides and you know they make a triangle, you can determine what type of triangle they are made, what type of triangle they make using all this information. If you have two sides and you're told that it's a right triangle, you can use the Pythagorean theorem to find the missing side. And there you go. There's that information.